see. Am I recording? Yes, I am recording. Why it's got the what? Uh-oh. That's what it is. Okay. So we are preparing for our quiz on Wednesday, right? Yeah. We're preparing for our quiz on Wednesday today. Yep. Because we're gearing up for the midterm on the following week, right? When on the midterm? When is midterm week? Snuck up on us. Huh? That's what I remember. That's what I remember. Oh, I took a picture of it. Yes, indeed.
So we got a quiz, exam, and midterm next week?
No, we're gonna make the first test the midterm. October 7th through 11th. Yes. October 7th through 11th. So, when is that? Next Monday? Okay. So next Monday. Yeah. So we gotta do the quiz this week, Wednesday. Then we're gonna have our exam, which we were planning anyway, right? As a midterm. All right. And we're gonna jump right into chapter 3, because we're gonna move a little quicker in the second half of the semester, so we can at least get to chapter 6. Okay. So we're gonna start moving. We're gonna pick up the pace. All right. So today, so I guess we can address any of your questions, concerns, or comments. All right. Good. So nobody has any questions. All right. So we're gonna see. Yeah.
So will there be any questions like if an object is thrown in the air and drop it? That's the free fall, right?
If an object is thrown in the air, there could be a question like that. But the difference is, you ready? All right. So in chapter 2, what we're talking about is one-dimensional motion. So if a problem were to appear on your exam like that, it would only ask about either, well, it's only going, if you said you threw it up, then the only thing I can ask about is going up. I can't ask you about it coming down, because we haven't talked about that. That's projectile. That's a projectile. If I throw something up, then it come back down, that's Earth's gravitational, right? Even though gravity is still affecting it when I throw it up, but the fact that I only consider the part going up makes it one-dimensional. What's the name of chapter 2? Kinetics in one dimension. So when we move to chapter 3, we're going to introduce vectors. And so that's when you're going to start talking about going up, then what? Coming back down. Because what goes up must come back down. So you see how the progression, how this is going, right? So we only dealt with one dimension in chapter 2, which we're going to take a quiz on Wednesday. And coming back down is projectile motion, but we got to deal with vectors before we get there.
So like the main 3 things that are going to be from chapter 2 is calculating like if we're given distance of time, getting speed, or
well, yes, that's one of the things.
And then the second one would be like if a car slows down.
Don't think about it situationally. Thinking about the concept.
If like two different speeds happen, and we might need to like locate distance during like how we had that problem on the board that the car with this amount.
Yes,
speed,
yes, yes,
and then
yes.
the one with the golden rule, I think it is, they call it.
Golden rule, yes.
And then questions like that.
Yeah,
So
yeah,
basically,
golden
like-
rule, huh?
Basically, like the questions that's like on the homework, those are like the
Yeah,
examples.
yeah, that's where I'm getting them from.
I was making it.
Yep.
Missing like three main things.
But you missed a thing.
This one?
Yeah, you missed the most prominent one. What is all this about? What causes free fall motion?
gravity.
Yeah,
Yeah.
right? Okay. That's the name of the game. That's what makes things move. Right?
Yeah.
At least in this direction. In this direction, we got, right, it's something different. But in the vertical direction, it's gravity. In the horizontal direction, right, we apply forces in the horizontal direction. That's what Newton said, right? In the horizontal direction, things remain at rest.
Until a force is acted upon it.
And what do we call that?
Gravity?
No,
Oh, my fault. Motion?
no.
Until a force is acted upon it.
I'm looking at you.
You did Newton's.
What do we call that? I said things at rest remain at rest unless
That's a law.
that's a law.
That's a law.
Yeah, and we talked about that.
Yeah.
I know. Yeah. Oh, it's information overload. I know y'all got a lot. Y'all got a lot of things coming, right? It's all good. I was in your spot once. Yeah, we talked about this. Things in motion remain in motion. Things at rest remain at rest. What is that? I'm not gonna tell you now at this point. It's up to you to find out. What else we got? That sounds like a good question to ask too.
Would there be anything like pertaining to graphs? 'Cause I know some of them were.
Yes. Yes. Yes, we might look at some, yes. Graphical interpretation. Like, is the object speeding up, slowing down, blah, blah, blah? Yeah. Yes, indeed. Anybody got anything else? Let's look at number 46. Got it?
Yes.
Let's look at number 46 on page 45. Somebody read that for me.
A stone is thrown vertically upward with a speed of 24 meters per second. How fast is it moving when it is at a height of 13 meters? How much time is required to reach this height? And why are there two answers to be?
Let's just take the first part of that question.
Okay.
Let's just take the first part. That sounds like something similar to what you just asked, right? So, somebody help me out. You're going through the problem solving procedure, right? This is what you're gonna do on Wednesday. Somebody help me out. What's the first step? What is it?
What's the speed?
So we looking for a speed. We're looking for a V. Right?
How much time is required to reach a certain height?
No. We're on the first part. We're dealing with the first part. That's the second part. We're dealing with the first part. Right? A stone is thrown vertically upward with a speed of what? Right? First part says what? What is how fast is it moving when it is at a height of 13 meters? Okay? So we'll skip the time stuff, right? The time domain stuff. And we go to well, let's just say seconds, okay? And we're gonna go to 3. What's 3? Right? We're gonna write down what we got. What do we have?
The speed.
Huh?
The height.
The distance.
Let's see some. All right. So we have what? Sorry. We have what?
The distance. And
We have a distance. What is it?
the speed. Oh, 13, sorry, 13.0 meters.
13 what? Meters. And we have a what?
Speed.
Initial speed. Right? Which is what? 24 meters per second. Right? So, what we're gonna do? What we're gonna use? What equation are we gonna use to solve for this problem?
Speed. X over T equals C.
Huh?
Speed equals X over T. And then you rearrange that.
So we have a what? An initial speed. We have a distance. What else do we have? A ball is thrown upwards. What is happening?
Gravity.
Right. So we have a what? Acceleration. 9.8 meters per second squared. Which is gonna be what? Negative. Because it's what? Why is it negative?
It's going
That's
down.
not why it's negative. Tell me why it's negative.
It's getting
Uh,
So it does what?
Second against it.
It's acting against it. That's why it's negative. It's acting, gravity is acting against the object, right? So eventually what happens? Huh? It comes back down, yeah, it falls. But what has to happen before that happens? Huh? It reaches 0. Right? If I throw something up, eventually it has to, before it can turn around and come back, it has to do what? Stop. Just like if you running in one direction and you want to go in the other direction, you have to stop. Sorry. This is the laws of physics. Right? So what equation? We still ain't answered the equation. The question. Huh? The golden rule. Who said that? That was you? All right, good. we're gonna use the golden rule, right? V final squared minus V initial squared equals what? 2A X final minus X initial. Right?
Wait, what's the name of that formula?
Right? So we have what? So in order to figure out, what are we looking for? What are we looking for? Time. Distance. Speed. That was the first thing we wrote. Y'all see why we, see you, that's why we do these problem solving procedures. That was the first thing we wrote. And you forgot all about it. We know the initial speed is this, right, from the problem. So we're looking for the speed, final, right? When what happens? When it reaches, no, when it reaches 13 meters. Y'all, a lot of this is reading comprehension. Reading comprehension. So, I'm just gonna do what? I'm gonna rearrange this equation, right? Let's write it over here. BF equals, right? We'll just take it one step at a time, and we'll just do what? B initial square, make that positive, bring it to the other side, plus 2A X final minus X initial, right? And then we got what? So we can put the numbers in, right? So, well, no, we can do the square root of this, right? Square root of VO squared plus 2AX final minus X initial, right? And that equals what? Square root of 24 meters per second squared. Square root of that plus 2 times what? Negative 9.8 meters per second squared. And X final is 13 meters. And X naught is 0. Anybody got an answer?
And if you're missing,
Huh?
Like 24.
24? No. That's it. What would that mean? It said the object was thrown up with an initial speed of 24.
I got 17.9.
That sounds more reasonable.
yeah.
Because why? Why does that sound reasonable?
So it's down.
It's slowing down because of gravity. Alright, so the second part, it says what? It says how much time is required, right? And that's gonna give us two answers because that requires us to use the quadratic equation. We have not done it yet. So we're gonna skip that part. Alright. Any questions about that? Concerns? Comments? Everybody think they're gonna be able to do that tomorrow or Wednesday?
Yes.
Yeah? Cool. Alright. So that was free fall, right? That was well, I guess it's not it's a special kind of free fall because it's doing what? Going up. But it's technically still free fall because it's being what? Affected by gravity. Okay? And nothing else. So that's what free fall means. Okay. Let's look at How about let's look at some graphical stuff. Let's do that. Let's do that. Oh, let's do this. Let's look at number 17. Number 17. Let's go back. 17. Somebody, please.
A sports car accelerates from rest to 95 kilometers per hour in 4.3 seconds. What is its average acceleration in meters per second squared?
Okay, we following our problem solving steps, right? I'm listening.
Looking for average acceleration.
Looking for average acceleration, right? Average acceleration. And the units for that is meters per second squared. Now what? Say seconds. Okay. Givens, right? What are they? Huh?
Initial speed.
Initial is 0.
Okay. Said initial is 0.
Yeah.
0 what?
Kilometers per hour.
Kilometers per hour. And final, gave a final? 95 kilometers per hour. What else?
Time is 4.3 seconds.
Time is 4.3 seconds. Right? Now we talk about physics, right? And what is the physics? Acceleration is what? What does it mean to accelerate?
Speed up.
To speed up. In mathematical terms, what does that mean? A change. If you're speeding up, you're changing, or you're slowing down. So, acceleration, average acceleration means what? The change and we write delta V as what? V final minus V initial, T final minus T initial. Somebody got an answer?
Yeah, 22.1.
What?
Kilometers an hour. No, you have to convert the whole. You have to convert kilometers to seconds. I mean, kilometers an hour to seconds. Okay.
Why? Why would you need to do that?
So it's working in seconds, and you can't do kilometers an hour divided by seconds.
All right. Good looking out.
Just change both of them to meters. Meters and seconds.
You say you're gonna change them to meters per second?
I was gonna change meters to second, yeah.
Meters to seconds.
Kilometers to meters and then hours to seconds.
Yes. But you don't necessarily have to change the.
Even though we're going to.
Oh, well, yeah, because you want your answer in meters per second squared. I forgot. Yeah, you're right. So that number was incorrect, the one you gave.
I got 6.13 meters per second squared.
What'd you get? You changed these?
Yeah.
What'd you get for these?
Well, the first one was just 0.
Zero.
The second one is 26.38 meters per second.
26.38 meters per second. Right? So then we can plug that there. Alright, and 4. Alright? And we're gonna say what? 26. I'm gonna say A bar is equal to what? 26.38 meters per second minus 0 meters per second. All over what? 4.3 seconds. And you said, what was it? 6 point what?
1.3.
6.3. 6.43?
1.3.
13 meters per second straight. Alright? So it seems trivial, folks. Sometimes these things can be trivial. Right? But it's building you up. Okay? And if you never take time to do these things until you get on the exam, then what happens is you have a lack of confidence. And so anything that you encounter which is out of the ordinary, which is, greatly depends on how much you have practiced, right? You become insecure and you start experiencing all different types of emotions, right? Sometimes you get mad at me. I've seen it happen, okay? So, what I would suggest is that you practice as much as possible. That's what this boils down to. It's nothing more, nothing less. Okay? Nobody in here is, everybody in here can add, subtract, multiply, and divide. Everybody. If you couldn't, you would not be here. So don't tell me nothing about calculus, all of that foolishness. And, you know, I would say the same thing about calculus. Calculus is built on addition, subtraction, multiplication, and division. There's only 4 operations in mathematics. So if you can do those 4 operations, then you are qualified to be here. But when you start experiencing different things, right, I just know that it could be related to those things, right? And that's fine. But, you know, there's other things that, you know, make it worse. And, you know, I'll pick up on that kind of stuff. All right? So, just make sure you're putting forth the effort. Okay? Because if you're not, then, you know, physics is like high blood pressure. You know what I'm talking about? I had high blood pressure. I still got a little bit. But it's something that'll sneak up on you. It's not gonna make you. You know, it depends though, right? It depends. So that's actually a very good analogy, right? Because, you know, some people go all their life and have high blood pressure and don't find out until what? Huh? Till they have a heart attack. And then it's done. Then you can't do nothing about it. Right? I was fortunate enough for my dentist to tell me. See? And then you have to put things in place. You say, somebody tell you, say, hey, you know, this is what you gotta do. Say, is it nothing else we can do? Or you can wait till the last minute and then get on the thing, ask the surgeon and say, Doc, what can I do, man? What can I do to help my heart? While you're on the operating table, you can do that. It's up to you. All right. How much time we got left? 12:35. All right, we ain't got but 15 minutes. So I got a few emails here. So, any questions? Any questions, concerns, or comments? Right? All of this being recorded. I'm gonna post this immediately when I get home. All right. So y'all can look back at this. Okay. But like I said, there is no magic, right? There is no magic in this. It is practice. That's it. And if you're having trouble with math, that's how you get better at math. That's it. Are we having lab tomorrow? Do we need to have lab tomorrow?
I'm just asking because I have a tutoring obligation, so I wanted to see if I could fix something online if I
Well,
do that,
I mean,
or
nobody's requested that we have lab.
so it's like it's not every week.
Yeah, but it's optional. I told y'all that.
I just get
Man,
confused.
we
I
don't
get
be that,
confused
man. We don't
with
be
I
that,
get confused with the lab and the recitation. Like I
The
don't
lab is every Tuesday.
Yeah.
The recitation is on Thursday,
Okay. So.
and it's optional.
Okay. So no.
And I gave it to y'all the first week, right? Or maybe that wasn't the first week. Y'all had a quiz coming up. That's why we did it. And I explained to y'all, say, this is why we're doing it for your quiz.
Okay. So
So what I'm asking you now is, do we need to have a recitation tomorrow
No.
or Thursday? Well, no, it's Wednesday, so we can't have a recitation. I mean, or we can have it, but it's gonna be useless because this quiz is Wednesday.
Yeah. Yeah, so on Thursday, yes, because the test is on Friday.
Yes, so we can have it Thursday for the test.
Thursday, yeah.
Yeah, we can. That's
So
fine.
tomorrow,
Yeah.
I'm not gonna be here, so
Yes.
I'll be fine.
Okay, yeah.
So what's our grade? Because isn't the lab like a separate class? What's our grade on? Like, is it just based on our performance in this class as well, or just like overall like?
No, it's based on you. Yeah, and lab as well.
Okay.
Yeah.
Okay.
You're in my lab?
Yes.
Well, no, the midterm is probably just going to be based on lecture. Because to get your final grade in lab, in order for it to be fair, right?
Yeah.
Because some people are not in my lab.
Yeah.
So your midterm grade will be just based on lecture. Yes.
Okay.
But your final grade is based on a combination of
Okay.
yes.
Yes. Thank you. Thank you for clearing that up.
I
Yeah.
have a doctor's appointment tomorrow.
Okay.
During our lab. Is it in-person lab or is it online, like last
And,
week?
I mean, if you got a doctor's appointment, though, it doesn't matter. If you got a doctor's appointment, then that's a valid excuse.
Okay,
Yeah.
you just want an excuse in case?
Yes.
Okay.
Yeah. You gotta have that excuse.
Got it.
Yep.
This one's on. You said the test is Friday, so we can use that as a midterm.
Yeah, I thought it was Monday,
What is Monday?
the midterm.
Well,
No, he was saying that's like the week of midterms.
yeah, it's just the week of midterms. I mean, we can do it on Monday if you want to do it on that, but you know.
What you were saying.
No, I was saying midterm week is next week. That's what I was saying.